Students, in last two lectures of chapter optics, we learn some basic things related to the lens, even the laws of reflection, refraction, optical fibers, total internal reflection. In today's lecture, we'll start with the refraction through the prism. Basically, first we are going to learn uh, about the prism. Prism is an optical element as in wedge shape and made from a transparent material like glass. In figure, it is very clear. It is the transparent material, and uh, prism have the different surfaces. Top and bottom is in triangular shape, and in these two uh, triangular shape, three vertical rectangular surfaces are there. One refracting surface, another refracting surface, and this one is the third refracting surface. Definitely three refracting edges are there. One is this edge, this one, and one more is here. Now these are the surfaces of the prism. Now base has to be considered in the prism. Suppose this rectangular vertical refracting surface is the base of the prism. Definitely no light, no refraction through this part of the prism, and in front of this plane rectangular vertical surface, the edge is there. This edge is known as the refracting edge of the prism. If we are using these two surfaces for the refraction of light, the angle here is known as the refracting angle of the prism. In 11th science syllabus, we are using equilateral prism. Therefore, the angle of refraction of the prism is 60 degree. So this is the basic idea about the prism, and in the next part we are going to learn the use of prism for refraction. Now monochromatic light is used for the refraction, or to learn the theory of the prism. Incident ray, we know that the ray is incident or passing from uh, a rare medium to the denser medium. This bends towards the normal. If the first medium, that is rare medium, whose refractive index is greater than the denser medium. Here air is the first medium, second medium is the glass medium, prism, and again this ray of light comes from denser medium to rarer medium. When it comes in the rarer medium from the denser medium, it bends away from the normal. When it ray is passing from the rarer medium to the denser medium, it bends towards the normal. So these facts we already studied in our previous uh, topics. Here monochromatic light and polychromatic light has to be considered. Monochromatic light, the rays from the source of light with equal frequency, the rays which is emitted from the source of the light, if it is with equal frequency, that sources were known as the monochromatic light sources. In example, we'll say sodium lamp, mercury lamp is the monochromatic source of the light, and in polychromatic source of the light, the rays from the source are not with uniform frequency. So that type of source is known as the polychromatic source, and example is sunlight, uh, or tube light, etc. Now, the next important article from the chapter is prism formula, and once again we are going to consider the diagram. Incident ray, it makes angle to the normal. That angle is the incident angle, and as I said, when a ray is passes through air medium to the denser medium, it bends towards the normal. This QR is the refracted ray. It suffers through the denser medium of the prism. It strikes to the another refracting surface of the prism, AC, and it come out. When it comes from denser to rarer medium, it move away from the normal. This angle is the emergence angle. Here we have to consider the two refraction. One is when light is from air medium to denser medium, and when denser medium to rarer medium. Here two refracting angles R1 and R2. Now we'll start to learn about the prism. ABC is the section of the prism, and refractive index of this denser medium with respect to air medium is N. And the section of the prism is shown in the diagram. Now, just I said, a refracting angle of the prism is this AB, and refracting surfaces are AB and AC. If this is the refracting angle, then BC is the base of the prism. Now, PQ is the incident ray, QR is the refracted ray, and RS is the emergent ray. I explained in the previous diagram. Then angle of incidence, R1 and R2 are the angle of refraction. E is the angle of emergence, and delta is the angle of deviation. Incident ray and emergent ray is produces back, so they intersect each other at point X. So this angle TXS is the delta, and this is known as angle of deviation of the prism. Now, monochromatic ray, already we explained, incident on the refracting surface AB, and incidence angle is I, that is PQM. It is I. Okay, at point Q is incidence point, and R is the point of emergence. Now, as I said, Q is the uh, incidence point. When ray is passes through the denser medium, is moves towards the normal, and it strike to the R, to the second refracting surface, and it come out. So R is the point from which the emergent ray is come out. Okay, so like that, RS is the emergent ray, and if we extended back this emergent ray and the incident ray, the X is the point of intersection, and we'll get the angle of deviation. Now here one point is important. Angle of deviation is the exterior angle of the triangle. Geometry of the figure has to be considered. XQR is the triangle, and delta is the exterior angle of this triangle. Definitely this delta is equal to XQR plus XRQ according to the exterior angle property. Delta is the exterior angle of XQR. So these two angles, sum of these two angles must be equal to delta. Now next statement is important. uh, this XQR, this angle is I minus R1, and XRQ is the another angle, and it is E minus R2. How this is? I is the opposite angle of XQR. Definitely this I and this angle, these two angle opposite angles, so they must be equal. So this is I, this must be I. If this is R1, so this angle must be I minus R1. So similarly we can explain for the emergence angle E. It is opposite angle of XRN, like that, this E minus R2. These two steps are important in the derivation of the prism formula. So we'll use it in the next slide. Okay, now quadrilateral has to be considered. Two normals are there. Definitely that angles are 90, and angle A and angle N. These are the opposite angle, and sum of this opposite angle is 180 degree of the quadrilateral AQNR. So this quadrilateral is the cyclic quadrilateral. Uh, Two right angles are formed at the normal, and angle A and angle N must be 180 degree. According to the cyclic quadrilateral property, we'll write A plus angle Q and R is equal to 180 degree. This is statement 1. Uh, just I explained, these are the angles at angles of the quadrilateral which is made by the normals. Then we have to consider the triangle, that is QNR. The triangle is made by the refracted ray to the uh, normal. Two normals intersect, that point is N, and this angle, that is R1 R2, and angle N Q and R, addition of the all angles of the triangle is equal to 180 degree. So this is the statement 2. If we compare this, right hand side of the equation is same, therefore left hand sides must be same. Even this Q and R and Q and R is same, therefore angle A is equal to R1 plus R2 from equation 1 and 2. Okay, this is the statement number 3. Refracting angle of the prism is equal to two refracting angles are there, R1 and R2. Sum of these two angles is equal to the refracting angle of the prism. Now delta is the exterior angle of the triangle XQR. Just now I explained in the previous slide. Again these two steps are here. Addition of these two, that is XQR and angle XRQ, is delta. Exterior angle of the triangle is delta, and we'll write I minus R1 plus E minus R2. Okay, how it is we explained in the previous slide. Now a simple mathematical step, if we remove the brackets, I plus E and minus sign is common, we'll write R1 plus R2 is equal to delta. Now from equation 3 we'll write I plus E minus A, because A is equal to R1 plus R2 is equal to delta. So minus A to this side, we'll get uh, I plus E, that is angle of incidence plus angle of emergence, is equal to refracting angle of prism plus angle of deviation. This is the half derivation of the prism formula. Okay. Now next part is related to the graph, and graph is plotted with angle of incidence and angle of deviation. Here angle of deviation is along y-axis and angle of incidence is along x-axis. So angle of incidence increases, the angle of deviation is decreases. At the particular point, this point, the angle of deviation becomes minimum. And furthermore, if we increase the angle of incidence, okay, from this, the angle of deviation is increases. I repeat, the graph is angle of deviation versus angle of incidence. Definitely angle of deviation is along y-axis and angle of incidence is along x-axis. Here angle of incidence is increases, the angle of deviation is decreases. At the particular angle of incidence, the angle of deviation becomes minimum, and furthermore if we increase the angle of incidence, the angle of deviation is increases. So here we explain the graph. Deviation, angle of deviation is delta, it becomes minimum, so this is angle of minimum deviation, that is delta m. These all things we explain. When this delta becomes delta m, angle of incidence and angle of emergence becomes equal. Okay, at the same time the angle of refraction, that is r1 and r2, becomes equal, and this is the path of reversibility. Okay, this must be considered here. A, a path of the light passing through the prism is what? PQ, QR, RS. PQ is incident ray, QR is refracted ray, and RS is emergent ray. But at this situation, when delta becomes minimum, angle of incidence is becomes angle of emergence, that is angle of incidence is equal to angle of emergence, and R1 is equal to R2. So this path, if we look from the point P or we look from the point S, the path of the light which is passing through the air medium to denser medium to air medium is same. There is no deviation. So this happens at a minimum angle of the deviation, and it is delta m. So next is very simple. At the path of reversibility, R1 is equal to R2, I is equal to E, delta is equal to delta M. Therefore, we'll write A is equal to R1 plus R2 is equal to 2R. R1 is equal to R2 is equal to R. Now refracting angle is R, and this becomes R plus R, therefore it is 2R. R is equal to A by 2. And here um, at this we'll write what? I is equal to E, therefore I plus I, and A plus delta M. Delta M is now angle of minimum deviation. So this equation will write I plus I is equal to A plus delta M. Definitely I is equal to, this becomes 2I. So I is equal to A plus delta M divided by 2. If we use the Snell's law, okay, it is n is equal to sine I by sine r. Now sine I is A plus delta M divided by 2 and sine r is A by 2. Therefore our equation becomes refracting index of second medium with respect to first medium is n, okay, is equal to sine of A plus delta M divided by 2 divided by sine of 2, and this is the angle of prism. Very important derivation, a big derivation, long derivation, okay, and we have to use, or we have to write by using the geometry of the ray of light passing through the denser medium of the prism. Okay, definitely the ray must be monochromatic ray of the light. If it is polychromatic, what happens? We are going to learn in the next part of this chapter. So the next simple article is deviation through thin prism. Thin prism is the prism whose refracting angle is less than 10 degree. We know if the prism is the equilateral prism, the refracting angle is 60 degree. But here refracting angle of the prism is less than 10 degree. Hence it is the thin prism, and a refraction through the or deviation through the thin prism will learn with a very simple way. We know that if the theta is very small, it is less than 10 degree, then definitely we'll write sine theta is equal to theta. Here what we'll write, I sin I by sin R1 at the point Q, and at the point R we'll write sin E by R2. Okay, so here sin I becomes I, sin R1 becomes R1 because these angles are very small. Deviation through the prism is very small. Okay, it is less than 10 degree refractive angle of the prism. So it is thin prism. Definitely these angles will be less, and we'll consider instead of sin I only I, sin R1 is R1. Similarly, we'll write over here, that is E by R2. Then this becomes I is equal to n R1 and E is equal to n R2. Next step. Is it? Then the equation I is equal to, sorry, I plus A is equal to A plus delta. We'll write A and delta, that is, sorry, I plus E and R1 and R2, addition of these two. Now N is common and R1 plus R2 is A. So this becomes NA, and this NA is equal to A plus delta. Now del A to this side. So delta is equal to A is the common. Now A to this side means it becomes minus. So A into bracket N minus 1. So this is the angle of deviation through the thin prism. Okay. Now next part is very important. It is dispersion through the prism. Now here if we consider the polychromatic ray of the light and it is passing through the denser medium of the prism, when it come out from denser to rarer medium, means the ray of light passes through the denser medium and it emerge from the another refracting surface, then it separate into its constituent color. Okay, this phenomena of the separation of the white light, polychromatic ray of light means it is a normal ray, it is white ray, and when it passes through the denser medium and it come out from the another refracting surface, the it separate into its constituent colors. This phenomenon is known as dispersion of light. Okay, and order of the color is VIBZ YOR: violet, indigo, blue, green, yellow, orange and red. Most extreme colors are violet and red, and yellow is the main color of violet and red color. So this is the diagram we learn for the dispersion. In between these two extreme colors, all other colors are there as I explained. Okay, and angle of deviation for violet color is delta V. It is more as compared to the red color, that is delta R. So dispersion is this: angle of deviation for violet color is greater than the yellow color, even deviation angle of yellow color is greater than the red color as shown in the diagram. But speed is different. Speed of the violet color is more as compared to the red color. That's what it is the first color in the spectrum. So this way we can learn the dispersion through the prism. Now the next important part is the is this, that is angular dispersion. Definitely when a ray of the light is dispersed through the material medium of the prism, it separate into constituent color. So there is angular separation between two back-to-back colors or two extreme colors. So this is known as angular dispersion. So definition is here: if a polychromatic beam is incident upon a prism, the emergent beam consists of all the individual colors angularly separated. This phenomenon is known as the angular dispersion for a prism. Okay. Now, if we consider, if we have to find out the angular dispersion between two extreme colors, that is violet and red color, then we'll write uh, this way, that is delta VR is equal to delta V minus delta R. Extreme colors violet and red. Okay, delta V is greater than delta R. That's what we'll write, delta V minus delta R. Now, by using the thin prism derivation or this equation, delta V is equal to definitely A into bracket and V. It is a refractive index for violet color. Okay, and for red color we'll write delta R is equal to A into bracket NR minus 1. NR is the refractive index for the red. Now we can consider the refractive index for every color. Okay, so we'll write here A into bracket NV minus 1 minus A into bracket NR minus 1. If we solve this, we'll write A into bracket NV minus NR. Definitely, if we remove the brackets, this A and V minus A and R, this becomes plus 1, this is minus 1, so this cancels. Or this becomes minus A and this becomes plus A. So minus A plus A cancels, and we'll write A and V minus A and R. So A is common. So angular dispersion will write with this formula. Angular dispersion or angular separation between violet and red color is A into bracket NV minus NR. Now the next definition, important definition, is the dispersive power of the prism. It is denoted by letter omega. Dispersive power of the prism is defined as, it is the ratio of the angular deviation of two extreme colors dispersed to the prism to its main color. Main color is the yellow color. So we'll write equation. This is angular separation between violet and red color, and its main color is the yellow color. That's why we'll write what, delta y is equal to mean color of violet and red, that is delta v plus delta r divided by 2. Even we'll write delta v minus delta r by delta y. Okay, so this way we'll write the dispersive power of prism according to the definition. It is the ratio of what, angular angular deviation between two extreme colors in the dispersed beam to its deviation of the mean color. So delta V minus delta R, angular separation between the extreme colors, and mean color is delta Y. That's why we'll write this. If we use this, okay, angular dispersion between two extreme colors is A into bracket NV minus NR. Just now in the previous lecture, previous article, we find out this equation. Okay, divided by delta y is A into bracket NY minus 1 according to the thin prism's derivation. So A cancels and omega is equal to this NV minus NR, refractive index of violet color minus refractive index of red color divided by refractive index of yellow color minus 1. So we'll find out the dispersive power of the prism. So these are the some simple article which relate to the prism, and it's very necessary to learn these simple articles. That's what I planned in this lecture. Next part is important, but we are going to learn this part in 12th. That is the uh, lens for the measurement, or simple microscope, compound microscope, telescope. These are the use of the lens in the uh, different optical instruments. So that we'll learn in the 12th standard. Here we'll learn some examples on this topic, and we'll stop here. So the first example is a monochromatic ray of light is incident at 37 degree on an equilateral prism of refractive index 3 by 2. Determine angle of emergence and angle of deviation. If angle of prism is adjustable, what should its value be for emergent ray to the just possible for the same angle of incidence? So we'll try to learn the first part of the uh, example. This is what a monochromatic ray of light is incident at 37 degree on an equilateral prism. Equilateral prism means angle of refraction is 60 degree, and refractive index is given. So we'll start to solve this one. Snell's law, n is equal to angle of incidence, and first time it is angle of refraction at the first refracting surface. So here refractive index is given and refracting angle is given. So we'll definitely find out the angle of refraction at the first surface. So here we'll write sine of 37. We'll find out from the logarithmic table in logarithmic science. See sine 31, you find out for this 31 it is 0.6018, and this n is 3 by 2 as it is. So this will gives us what sine inverse of this, that is 0.4012 if we solve this. And if we find the angle which relate to this mantissa, so r1 is equal to 23 degree 39 minutes. Okay, this is r1. Similarly, we know the prism is equilateral prism, therefore A is equal to 60 degree. Uh, Definitely A is equal to R1 R2, R1 plus R2. R1 is this, okay, or R1 is 23 degree and 39 minutes. If we subtract from the refracting angle of prism, we'll get R2. So definitely R2 is equal to 36 degree and 21 minutes. If we know R1 and R2, definitely we'll find out. Uh, okay, before that, we have to find out R2, that is refracting angle at surface, another surface. When a ray of light is emerged, it passes from denser to rarer medium. So this is 3 by 2, and angle of emergence has to be find out. Angle of refraction, that is at second surface, is 36 degree 21 minutes. So angle of emergence will be definitely uh, E is equal to this, and sine inverse of 0.889. This 3 will be multiplied to the numerator, and after dividing by 2 we will get this one. So if we find the sine inverse from logarithmic table, we'll get angle of emergence. It is 62 degree and 44 minutes. Now here we'll use this equation. I plus A is equal to A plus delta. A is 60 degree and delta is, okay, so delta has to be found out. I angle of incidence, angle of emergence, okay, so this will be 37 plus 63 minus 60, and definitely delta will be 40. So this is the first part of the example. Angle of deviation is 40 degree. For the rest part of this example, we'll consider the refracting angle at the point of emergence. It is R2 dash, and it is as a critical angle. Okay, so a critical angle R2 is equal to sine inverse of 1 by n. N is 2 by 3 by 2. So we'll write inverse of this n, it is 2 by 3. Divide to this by 3, 2 by 3. This becomes 0.666. So if we find out the uh, angle, it is 41 degree and 48 minutes. This will easily find out from the natural science. 0.666 mantissa, okay, and related angle of this mantissa is 41 degree 48 minutes. So R2 is this. Then we know that A is equal to R1 plus R2. So A dash, the next shifted angle of the refracting angle of the prism. So we'll write R1 is 23 degree and 39 seconds, and here R2 is 41 degrees and 48 minutes. So we'll get a new refracting angle. Little bit complicated example, uh, okay, but we'll try to find out the angle of deviation. Now the next example is, from the given data set determine the angular dispersion by the prism and dispersive power of the material for extreme colors. NR means refractive index for red color is given, refractive index for violet color is given. Okay, again deviation angle for the red color is given, it is 3.1 degree. So we'll try to solve the example. Given is what? Refractive index for red color is given, it is 1.62. Refractive index for violet color is given, it is 1.66. And uh, deviation angle for red color is given, it is 3.1 degree. Okay, so a prism is the thin prism. We'll write delta R is equal to A into bracket R minus 1. So from this we can find out the angle of uh, thin prism. Delta R is given, it is 3.1, and uh, NR is given 1.62. So values here, we'll write 3.1 divided by 1.62 minus 1. Delta R is 3.1 and NR is 1.62. So we'll get 3.1 divided by 62, sorry, 0.62, and this becomes what? Uh, point, uh, 1 by point 2. So this becomes 5. Refracting angle of the prism is 5 degree. Now delta V is, okay, NV is given. NV is what? Refractive index for violet color. So A is 5. Now refracting angle of the prism is A, and it is 5. And into bracket 1.66, that is refractive index of violet color. So this becomes what? 0.66 into 5. So this gives us what? 3.3 degree. It is the angle of deviation for violet color. Angle of deviation for red color is given. Now we'll write angular separation between violet and red color. It is angular dispersion between these two extreme colors. So here 3.3 minus 3.1, it is 0.2 degree. Okay, so dispersive power, this now 0.2 degree, and delta V plus delta R, that is 3.3 plus 3.1, definitely it is 6.1 divided by 2. So we'll write it is 0.2 divided by 6.4 into 2. This 2 denominator, it comes to the numerator. So here it is 3.2, 0.2 divided by 3.2, and this becomes 1 by 16. 1 by 16 is 0.0625 is what? dispersive power of the material of the prism. So this way we'll learn the chapter. We'll stop here and I'm closing the syllabus for 11th science. Thank you.